Then we have to move excitation energy. What is mean by excitation? Excitation is nothing but we are travel from one place to another place. One place is nothing but ground state, another place is nothing but excited state. So, we have to excite an electron from ground state to the excited state. How much amount of energy is required to excite an electron from the ground state to the excited state? That's the energy is called as the excitation energy. So, excitation energy is nothing but how much amount of energy to excite an electron from the ground state to the excited state. Here I am written lower energy state to the any higher energy state. Yes, we have to calculate first excitation energy. How to be calculated means we have to consider ground state and the first excited state. The value of ground state is E1, value of excited state is E2. E1 is replaced by minus 3.4, E2 is replaced by minus 3.4, E1 is replaced by minus 13.6. So, while simplifying it become 10.2 electron volt. This energy is nothing but first excitation energy. Then calculate the second excitation energy. Second excitation means we have to consider E3 and E1. The value of E3 is minus 1.51, value of E1 is minus 13.6. While simplifying these two values, we can get 12.09 electron volt. This is called the second excitation energy. So, like that we can calculate first excitation, second excitation and third excitation like that. Next we have to move the excitation potential. What is the meaning of excitation potential? How much amount of excitation energy per unit charge is nothing but excitation potential. So, simply we can call capital E is equal to small e into V. Here capital E is the energy of the excitation, small e is the charge of an electron, V is the excitation potential. We can calculate excitation potential value also. We will see one by one. Now calculating first excitation potential. E1 is equal to EV1. Here E is the small e is the charge of an electron, V1 is the excitation potential, capital E1 is the excitation energy. So, V1 is equal to E1 divided by E. The value of E1 is 13.6 electron volt. E getting cancelled. So, we can conclude V1 is equal to 13.6 volt. Then move to the E2. E2 is equal to E into V2. V2 is equal to E2 by E. So, the value of E2 is 12.09 electron volt by charge of an electron E. So, E getting cancelled, it becomes 12.09 volt. This is the second excitation potential. Then we can calculate E V3, V4 like that. Then move to the ionization energy. Ionization energy means how much amount of energy required to remove an electron from the ground state. So, we have to remove an electron from the ground state, we need some amount of energy. That energy is nothing but ionization energy. So, we can define the minimum amount of energy required to remove an electron from the ground state. Now, calculating ionization energy. So, here while calculating ionization energy, we have to consider the two energy state. One is the infinite state and another is the first state. First state is the ground state and the infinite state is the excited state. And the energy of the excited state is 0 electron volt. This is the utmost maximum energy, and a ground state is having the very least energy, that is minus 13.6 electron volt. While simplifying both the values, we can calculate 13.6 electron volt. This is the ionization energy. And while calculating ionization energy for infinite state and the nth state, while infinite state is 0 and the nth state is minus 13.6 by n square z square electron volt. Minus into minus become as plus only. So, 13.6 divided by n square into z square electron volt. This is the ionization energy. From this ionization energy, we can calculate ionization potential also. So, what is mean by ionization potential? ionization energy per unit charge is called the ionization potential. So, for example, ionization potential is equal to ionization energy by charge of an electron. We know the value for ionization energy in the nth orbit 13.6 divided by n square z square electron volt by, which is the value present in the denominator, is E. So, E getting cancelled, we can get V is equal to 13.6 divided by n square volt. Where is value of Z means the Z is equal to 1. So, atomic number of hydrogen Z is replaced by 1. So, the before equation becomes 13.6 divided by n square volt. This is nothing but ionization potential. Ionization potential is nothing but ionization energy per unit charge. So, up to these things we are calculating radius of the orbit, velocity of the orbit and the energy of the orbit as well as the ionization energy as well as the excitation energy. So, these are all the basic concepts present in the Bohr atom model. From the Bohr atom model, next we are going to be calculating the spectrum of hydrogen. This topic we have discussed lesson number 5 in the first volume very briefly. So, the name of the fifth lesson is electromagnetic waves. In that electromagnetic waves, we have discussed very deeply the spectral lines. Here, we are going to discuss hydrogen spectrum. Hydrogen spectrum means this hydrogen spectrum contains two categories. One is the emission spectrum and another is the absorption spectrum. Emission is nothing but it going to be emits some amount of energy. Absorption is nothing but it absorbs some amount of energy. Either absorbing or emitting some amount of energy, it is going to be producing the spectral line. The spectral line contains at a particular wavelength or a certain wavelength. So, this much amount of the spectral line is possible only when the electron is going to be jumping from one state to the another state, the spectral line is going to be produced. Simply we have to call when the hydrogen gas enclosed in a tube is going to be heated. Let us consider the enclosed gas tube. Inside of the gas tube, the hydrogen is present. The hydrogen gas tube is going to be heated. It emits electromagnetic radiation. So, while emitting the electromagnetic radiation, such radiation having some certain wavelengths. The certain wavelengths is nothing but very sharp wavelengths are present. So, we can call when the hydrogen gas enclosed in a tube is going to be heated up, it emits electromagnetic radiation of certain wavelength, is nothing but emission spectrum. While move to the absorption spectrum means the thermal energy supplied to the excite the electron by passing the light on the atoms, the electron can be excited by absorbing photons. So, in this case, it is able to absorb, accept the photons of energy. While intaking these things, the thermal energy is supplied to the excite the electron. When means by passing the light on the atoms. By passing the light on the atom means which are the electrons are present in the state is going to be excited by absorbing the photons. Then it have absorbing energy with particular wavelength. While getting the particular wavelength, it's called the absorption spectrum. While getting the certain wavelength, it exists emission spectrum. So, we conclude that the hydrogen spectrum having two categories, one is the emission spectrum and another is the absorption spectrum. Now, we are going to discuss about spectral series of hydrogen atom. Already we discussed the types of spectrum present in the hydrogen. What are they? Emission and absorption spectrum. In both the spectrum, it contains some spectral line. Where the places the spectral line are present, the electron is going to be jumping from higher energy state to the lower energy state, it going to be emitting a spectral line. The spectral line continuously emitting means that the process is called as the spectral series. Which is the atom is having spectral series means it is possible only by using hydrogen atom. See here, some of the diagrammatic representation is present. In the diagrammatic representation, we are considering 6 energy states. Look here, N is equal to 1, that is called the ground state. The value of ground state is minus 13.6 electron volt. And the N is equal to 2, this is nothing but first excited state. The value of a first excited state is minus 3.4 electron volt. And N is equal to 3, this is the second excited state, that value is minus 1.51 electron volt. And next N is equal to 4 means minus 8.5 electron volt, and so on. While communicating, N is equal to 1 means this is called the ground state as well as the first orbit. And N is equal to 2 means this is the first excited state as well as second orbit. N equal to 3 means this is the second excited state, that is nothing but third orbit. Then N is equal to 4 means third excited state as well as this is the fourth orbit, and so on. Suppose while an electron is going to be jumping from higher energy state to the lower energy state, the spectral lines are produced. How is it possible? We will discuss one by one. Just look at the diagram. In the diagram, 5 spectral series are present. They are known as Lyman, Balmer, Paulson, Brackett and Fund series. What is the meaning of this series means? Lyman series is nothing but any of the outermost orbit to the first orbit. Balmer series is nothing but any of the outermost orbit to the second orbit. Paulson series means any of the outermost orbit to the third orbit. Brackett series means any of the outermost orbit to the fourth orbit. And Fund series means any of the outermost orbit to the fifth orbit. What is the meaning of these things means? The electron is going to be jumping from any of the outermost orbit to the first, second, third, fourth and fifth means the spectral series are present consecutively. So, this is the concept while discuss the spectral series of hydrogen atom. We will see one by one. The wavelength of the spectral lines from the Bohr atom model. How to be calculate? What is the formula to use to measure the wavelength of the spectral line? From the Bohr atom model, we have to get nu bar. Here nu bar is nothing but wave number. Nu bar is equal to 1 by lambda. Nu bar means number of waves present in 1 meter length. What we have to call? Number of waves per unit length is nothing but wave number. Otherwise, we can call reciprocal of wavelength. What is that? Reciprocal of wavelength. So, what is the unit of wavelength here? It is always in Armstrong or meter. And wave number nu bar is equal to 1 by lambda is equal to R into. What is R here? R is nothing but Rydberg constant. R into 1 by n square minus 1 by m square. Then n and m are the integers. The value of n is going to be replaced by 1, 2, 3, 4, 5 like that. And m is replaced by outermost orbits. Here the condition is present, m is greater than n. While comparing the value of n always lesser than that of m, or we can call m is always greater than that of n. So, we conclude that the wave number is nothing but number of waves present in 1 meter length, or we can call number of waves per unit length. Otherwise, it is also defined as reciprocal of wavelength. Is also known as reciprocal of wavelength. Here, see the value of Rydberg constant. R is equal to 1.097 into 10 to the power of 7 meter inverse. This is the constant value. The value of Rydberg constant is R is equal to 1.097 into 10 power 7 meter inverse. Then let me see one by one the spectral series of hydrogen atom. First series is nothing but Lyman series. What is the meaning of Lyman series? The electrons are going to be jumping from any of the outermost orbit to the first orbit and the spectral lines in the UV region. UV is nothing but ultraviolet region. So wherever the places, whatever it may be, the spectral lines are present in the ultraviolet region means that series is nothing but Lyman series. How is it possible means the electron must travel from outermost orbit to the first orbit. So the electron must jumping from outermost orbit to the first orbit, we can call Lyman series. The value of n is 1 and the value of m is replaced by 2, 3, 4, 5 up to etc. Like that we have to apply the value for n and m. So we substituting the values in the given equation, nu bar is equal to r into 1 by 1 square minus 1 by m square. Here m not to be replaced because m having n number of values 2, 3, 4, 5 like that. While substituting the value of nu bar is replaced by 1 by lambda is equal to r into 1 by 1 square become as 1 only minus 1 by m square. While calculating the wavelength of the Lyman series means 1 by lambda is equal to r into 1 minus 1 by m square. Now Balmer series. This is the second series of the spectral series of hydrogen atom. Second series, the electrons are going to be jumping from outermost orbit to the second orbit. What will happen means here the electrons is jumping from any of the outermost orbit to the second orbit. Any of the outermost orbit to the second orbit means the value of n is become 2 and outermost orbits are maybe 3, 4, 5 like that. Here the electrons are jumping from outermost orbit to the second orbit, the spectral lines in the visible region. This visible region contains 7 different colors like VIBGR. Here we have to replace n by 2, m we can replace 3, 4, 5 like that. While substituting the values in the equation of the wave number, nu bar is equal to r into 1 by 2 square minus 1 by m square. Here the value of 2 square become as 4 and the equation of nu bar is equal to 1 by lambda. Already we know that the reciprocal of wavelength is nothing but wave number. From this we can calculate the value of wavelength of the Balmer series. So 1 by lambda is equal to r into 1 by 4 minus 1 by m square. Next move to the Poisson series. Poisson series means the electrons are jumping from outermost orbit to the third orbit and the spectral lines in the near infrared region. IR means infrared region. Here the electrons must jumping from outermost orbit to the third orbit and the spectral lines are in the near infrared region. Third region is present in the infrared region. Here the value of n is replaced by 3 and m is replaced by 4, 5, 6 like that. So substituting the known values in the before equation, nu bar is equal to r into 1 by 3 square minus 1 by m square. 3 square become as 9. So nu bar is replaced by 1 by lambda. So 1 by lambda is equal to r into 1 by 9 minus 1 by m square. From this equation we able to calculating the wavelength of the Poisson series. Next move to the bracket series. Bracket means the electrons are jumping from outermost orbit to the fourth orbit and the spectral lines in the middle infrared region. Here the infrared region is the middle region and the electron must jumping from outermost orbit to the fifth orbit. Here the value of n is replaced by 4 and m is replaced by 5, 6, 7 like that. Substituting the known values in that equation, nu bar is equal to r into 1 by 4 square minus 1 by m square. And nu bar is replaced by 1 by lambda and is equal to r into 1 by 16 minus 1 by m square. Next, fun series. Fun series means here the electrons are going to be jumping from any of the outermost orbit to the fifth orbit, and the electrons jumping from any of the outermost orbit to the fifth orbit, and the spectral lines in the far infrared region. Far means we have to call distanced infrared region. Here the electrons must jumping from any of the outermost orbit to the fifth orbit. So the value of n is 5 and m is replaced by 6, 7, 8 like that. We have to substituting the values in the equation, nu bar is equal to r into 1 by 5 square minus 1 by m square, and nu bar is replaced by 1 by lambda is equal to r into 1 by 25 minus 1 by m square. From this equation we able to calculate wavelength of the fun series. Till now we are discussed the spectral series of hydrogen atom. Totally 5 series are here. They are called as Lyman series, Balmer series, Parsons series, Brocket series and fun series. While comparing the energies of these 5 series means we have to keep in mind while entering into the concept of the energy, what is the relation between the energy and the wavelength. Here all the equation we are calculating the wavelength of the individual series only. From this wavelength we able to calculate energy of the individual series. How is it possible means energy and the wavelength always inversely proportional to each other. From this relation we can conclude energy and frequency also inversely proportional to each other. So individually we have to express the energy of the series means the first thing is energy of the Lyman series, and second is the energy of the Balmer series, and third is energy of the Parsons series, and fourth is energy of the Brocket series, and fifth is energy of the fun series. While comparing these 5 series of the energies, which one is greater? We have to keep in mind the energy of the Lyman series always greater than that of Balmer series, and energy of the Balmer series always greater than that of energy of the Parsons series, and energy of the Parsons series always greater than that of energy of the Brocket series, and energy of the Brocket series is always greater than energy of the fun series. While comparing Lyman and the fun series means the energy of the Lyman series very much greater than that of energy of the fun series. So the Lyman series leads to number 1 and the fun series leads to number 5. While arrange the order, the energy of the Lyman greater than energy of the Balmer greater than energy of the Parsons greater than energy of the Brocket greater than energy of the fun series. As well as we can conclude the energy of the orbits also. How it comes means the energy of the first orbit, energy of the second orbit, energy of the third orbit, energy of the fourth orbit, energy of the fifth orbit. Already we know the value for the individual values. What are the means? The energy of the first orbit is minus 13.6 electron volt. Energy of the second orbit means minus 3.4 electron volt. Energy of the fourth orbit means minus 1.51 electron volt. Energy of the fourth orbit means minus 0.85 electron volt. And the energy of the fifth orbit means minus 0.54 electron volt. While comparing these values, minus 0.54 is the greatest value comparing with the minus 13.6 electron volt. So we conclude that the concept, the energy of the first orbit always lesser than that of the outermost orbits. Like E1 lesser than E2, lesser than E3, lesser than E4, lesser than E5. While comparing E1 and E5 means E1 is always less than that of the E5. From these two relations, we conclude that the concept, the relation between the energy, wavelength and the frequency. How it means? Let us consider a photons of energy. Each photon having photons of energy is equal to h nu. Is equal to h nu. We know the relation. Nu is replaced by c by lambda since nu is replaced by c by lambda. So, E is equal to hc by lambda and c equal to nu lambda. From the second relation, c is acts as a constant means nu and the lambda both are inversely proportional to each other. And the first relation, hc is acts as a constant, E and lambda are inversely proportional to each other. While comparing both the equation and express in a single term from this relation, E is directly proportional to nu is directly proportional to 1 by lambda. While read as energy always directly proportional to the frequency. Frequency always inversely proportional to the wavelength. And here the question comes like this: what is the relation between energy and the wavelength? Here energy is increases and the wavelength is decreases. So, we conclude that the concept energy is increases, correspondingly wavelength is decreases. So, we can call energy and the wavelength are inversely proportional to each other. From this we can give the conclusion for a given table. By using of this table, see here the first column is Emax. Emax means maximum energy. And second is nu max, maximum frequency. And third is the lambda minimum, that means minimum wavelength. Wherever the places, whatever it may be, when the minimum wavelength is present means the energy and the frequency always maximum. See the second column, minimum energy and minimum frequency but maximum wavelength. So, we conclude that energy and the frequency are directly proportional, energy and the wavelength are inversely proportional, frequency and wavelength also inversely proportional. See here the numbers are present. So, what is the meaning of this table gives 6 tends to 1. We have to read as 6 tends to 1. What is the meaning of this? This is the transition of an electron. Transition means, for example, the electron is going to be jumping from 6th orbit to the 1st orbit. The meaning of 6 to 1 means the electron is jumping from 6th orbit to the 1st orbit and 5th orbit to the 1st orbit, 4th orbit to the 1st orbit, 3rd orbit to the 1st orbit, 2nd orbit to the 1st orbit. So, among these 5 categories, the rank number 1 is 6 tends to 5. So, among these 5 categories, the 6 tends to 1 means it gets maximum energy, maximum frequency but minimum wavelength. And rank number 2 is the electron transiting from 5 to 1. That means the electron jumping from 5th orbit to the 1st orbit. So, while comparing 6 to 1 and 5 to 1, 6 to 1 having the maximum energy, 5 to 1 having the minimum energy, comparing with the 6 to 1 only. Like that, while giving the rank of these 5 categories, rank number 1 is 6 to 1, rank number 2 is 5 to 1, rank number 3 is 4 to 1, rank number 4 is 3 to 1 and rank number 5 is 2 to 1. What is the rank means here means among these 5 categories only maximum energy, maximum frequency, minimum wavelength. See the next term. Next term is entirely different from the first categories. Here all the outermost orbit to the first orbit only the electron is jumping. But the second category is the electron jumping from 6th orbit to the 5th orbit. Electron jumping from 5th orbit to the 4th orbit. The electron jumping from 4th orbit to the 3rd orbit, the electron jumping from third orbit to the second orbit and the electron jumping from second orbit to the first orbit. So among these 5 categories, maximum wavelength, minimum frequency, minimum energy leads here. So these 5 categories, rank number 1 is 6 to 5, rank number 2 is 5 to 4, rank number 3 is 4 to 3, rank number 4 is 3 to 2, rank number 5 is 2 to 1. So while comparing part 1 and part 2, part 1 having the maximum energy, maximum frequency, minimum wavelength, and part 2 is minimum energy, minimum wavelength, minimum frequency and maximum wavelength. So this table is going to be used while solving the numerical problems also. While comparing the energy of each transition, we have to keep in mind it is the very most important topic in this atomic and nuclear physics. Till now, we concluded that the Bohr atom model. While discuss about the atom model, we are covered J.J. Thomson atom model, Rutherford atom model until Thomson atom model. J.J. Thomson, Rutherford as well as the Niels Bohr atom model. Among these 3 atom models, once again we are maintain the some of the limitations. What are they means? In this Bohr atom model, it is valid only for the hydrogen atom but not for complex atom. What is the meaning of this means? Except the hydrogen, we not able to apply for other atoms. The other atoms are all called as complex atoms. So the Niels Bohr atom model is valid only for the hydrogen atom because the atomic number of hydrogen atom is Z equal to 1. So Z equal to 1 means we may not mention it. It is not make any impact with the given equation. So that's why the Bohr atom model give some of the limitation. That is number 1, it is valid only for hydrogen atom but not for complex atom. And the second one is, it could not explain the fine structure of spectral line. This thing already failed in Rutherford atom model also. So once again we are make atom failed in Bohr atom model also. What is that? It could not explain the fine structure of spectral line. Till now we are specifying the spectral series of hydrogen atom. They are Lyman, Balmer, Paulson, Brackett and Fun series, but we not able to express the fine structure of the spectral line. We not able to express exact fine structure of spectral lines. Once again we failed it. And third is it fails to explain the intensity variation. Once again we are failed to explain the intensity variation. Intensity means we have to call the brightness of the series. Brightness means it is depending upon the wavelength also. So we have discussed 5 different series by using of hydrogen atom, but we not able to express, we not able to explain the intensity variation present in these 5 series. And the last but not least here, the distribution of electrons not completely explained. What is the last one? The distribution of electrons not completely explained by Niels Bohr atom model. Distribution of electron means the electrons always revolving around the nucleus. It is not completely explained by Niels Bohr atom model. So we conclude that the concept, all the atom models are explained very clearly, but all the atom models are failed to explain some of the difficulties.